Hi everyone, welcome to the Homework 4 Part 1 Bootcamp. For Homework 4 Part 1, you will implement a recurrent neural networks to generate text with language modeling. You will also implement some regularization techniques, which is discussed in the paper attached on the end of this slide. One thing to note is that you will use PyTorch package in this homework. You are allowed to use GPU in this homework. It is not a must, but it will make your training faster, especially for those training for longer time. In this homework, you will need to implement 4 classes. One is the data loader for language modeling. Second is your language model. Third, you will implement a class of trainer, which includes optimizing and the criteria. And last, the class you need to implement is a test language model. The main function you will implement in data loader is the iteration function. You will first concatenate all the articles in the dataset to a single long list, and parse the list to be a batch of input and target. You can do this by first calculating the number of input-target pairs based on the length of concatenated list of words and sequence length you specified. Then, create the two empty 2D arrays, which is the shape of batch size times sequence length, and insert the corresponding indices of words one by one. Iterate through the concatenated data and yield the input target pairs. For yield, you can search for Python year to get more information about this. For the sequence length, it is described in detail in the write-up, so please take a look into the write-up. You can also do variable length BPTT here, which is a regularization technique will be covered later in this bootcamp. For the language model, you will need an embedding layer, the LSTM layers, and a linear classifier. If you keep the shape of your embedding and classification layer consistent, you will be able to apply the weight tying technique here. It is also mentioned in the paper attached in the end. The weight tying will share the weights between your embedding layer and your linear classifier. Keeping the shape consistent, meaning to keep the embedding size of your embedding layer equals to the classification input feature size of your linear classifier. For the trainer, what you need to do is same as or similar to what you have done so far in the part 2. Remember that we will model the problem as a classification task, so think about which loss is appropriate in this homework. You will also need to define appropriate optimizer and follow the standard forward pass, backward pass flow in train batch method. For the test language model class, there are 2 methods. One is the prediction and the other is generation. In prediction method, you will pass the given input through the model and return the last time step word in the output. In the generation method, predict the next word given an input using the prediction method. You can also follow what has been described in recitation 8. In a loop, use the previously generated output as the next input to your model and generate the prediction for the next word. The parameter for forward will tell you the number of times you need to run this loop. Then let's take a look at important regularization techniques. Weight decay is what we have used so far in the homework part 2, and weight tying is what I have already described in the model. You can also see the details about weight tying in the paper. For variable length BPTT means back propagation through time. We are using a fixed sequence length for breaking up our data. And you saw the sequence length of 3 in the example of write-up. However, no matter how many times we iterate over the dataset, the first element in the sequence will never have anything to backprop into. So, given the sequence length of n, we are not utilizing the information from 1 over n of the dataset. which is for every sequence, the first word will be never get backpropagation. So it is very highly inefficient. To prevent this problem, variable-less BPTT will randomly select sequence length in every epoch instead of keeping it constant. For example, besides keeping the sequence length of 3, we will randomly choose the sequence length from, for example, 3 to 10 at each epoch, so that we can assure that almost all the words will be considered. You can also apply locked and embedding dropout to the homework. Typically, we apply a different dropout mask to each example in a batch. However, applying a dropout on RNN is dangerous, in a sense that the purpose of an RNN is to keep a memory of events over the long term. However, classical dropout methods are not efficient since they create a noise that prevents these models from keeping a memory on the long term. In locked dropout, the same dropout mask is applied across sequences. Essentially, we repeat the same dropout mask at each time step for input. Embedding dropout is equivalent to performing dropout on the embedding matrix at the word level, where the dropout is broadcast across all the word vectors embedding. There are good references in this link. Finally, let's talk about activation and temporal activation regularization. L2 regularization is often used on the weights to reduce overfitting. L2 decay can also be used on the individual unit activations. This is termed activation regularization. Abbreviation is AR. Activation regularization penalizes activations that are significantly larger than 0 as a means of regularizing the network. In temporal activation regularization, L2 decay is applied to the difference in output of an RAN at different time steps. It penalizes the model from producing large changes in the hidden state. Here is the link to the reference paper. If you face some problems when you implement a language model, please take a look at the Restation 8. Restation 8 has gone through the language model and how to use the language model to generate the stream. The method used in the Restation 8 is character-based language modeling. However, it is preferred to use word-based language modeling in this homework. Thank you.